Ladies and gentlemen, welcome to Circuit Analysis course. This is an introductory video. So in this course we will consider having direct current flowing through the circuit. That's what this DC stands for. So let me start by telling you what a circuit is. A circuit is a set of electrical components and interconnections designed to perform a specific function by allowing electric current to flow through it. A circuit consists of elements, and there are five basic elements that we will talk about in this course. And let me tell you what they are. The first one is a voltage source. The second one is a current source. The third one is a resistor. The fourth one is an inductor. And the last one is a capacitor. So these are five basic elements that a circuit can have. So let me draw a simple circuit as a representative. Here's a voltage source, a resistor, and let's close this. So this is basically a circuit, a simple circuit. So let me talk about voltage and current sources in detail. So voltage and current sources. So these divide into two groups. They can be independent. This is the simplest version that you can have of them. And dependent. Independent voltage source, for instance, looks like this. It's represented by a circle with polarities. Polarity is basically these plus and minus signs. And in a given problem, a voltage is more likely it will be given, and they will need to find current flowing through this, for example. So that's what an independent voltage source is. Let's talk about independent current source, which has a similar symbol. The only difference is that we have a current like this. Again, it's given to us more likely, and we'll need to find voltage, for example, through this, across it. So a dependent voltage and current sources, in contrary, look kind of similar, but they have a different symbol, and that symbol is a rhombus. Let me draw it a little bit bigger. And the difference is that the voltage of this source will be a function of another voltage across some other element in a circuit. For example, let's write like 2V1. So this is a function of voltage across element 1, for example. Okay, so this is not here. The voltage was a number, it was a constant. But here, voltage is a function. That's why it's called dependent source. A dependent current source has again a rhombus, and it has current flowing through this. And it's again a function, as was the voltage before. Let's say it's a function of I3. And again, we can add a number, for example, because this is a function, right? So I is a function of I3, which is a current flowing in a particular part of a circuit, for example, or it can flow through some other element in a circuit. It's an element number 3 in this case. Okay, so let me talk about passive sign convention as well, because passive sign convention is one of the most important things that we need to know in order to progress in this course, because we will use this all over the course, throughout the course, in each problem. So what is passive sign convention? Let me draw element here, circuit element, and let's say it has polarities plus and minus, and let it have a voltage V. Okay, so a passive sign convention is just an assumption. It's nothing more than that. It's just an assumption of the direction of the current. And in this sign convention, we assume the current to flow in the direction of the voltage drop. In simple words, it's from plus sign to minus sign. We assume current flowing and always flowing in the direction of voltage drop. So that's all passive sign convention consists of. It's not more complicated than that. In further lessons, when we will solve examples, we'll always use passive sign convention, so you'll just get hang of it. So, and the last things that I want to talk about is power and energy. And I'll talk about them really briefly, because we'll talk about them more and more as we progress. So what is a power? Power and energy. Power is basically represented by letter P, okay, and it has a unit of watts. Obviously, you can have, for example, milliwatts, microwatts, or even megawatts. I hope you know all this. So, power, physically, power is an energy flow. And it has a formula of energy divided by time. So power is energy per time. Or in other words, it's a flow of energy. For example, power can be 10 joules per second, 20 joules per second, 1 microjoule per second, for instance. So power, this is the most general form. This is the most general formula of power that we know from physics. But in this course, we'll need to know another formula for the power, which is this one. Power is also a multiplication of a current I and voltage V. It's as simple as it is. So this is the formula that we need to know in this course. So energy, additional energy, is basically represented by letter W, and it has a unit, joules. Again, it can be microjoules, kilojoules, even picojoules sometimes. So let me explain this in this way. For example, let's assume energy is your money in your bank account. And power is basically the deposits that you make into your bank account. For example, let's say you have $1,000 in your bank account. This is energies that you have already in your bank account. And let's say you deposit $100 per month. This is your power. Basically, the amount of money that you deposit each month. Or of course, it can be like per day. In this case, let's say it's per month. So this is basically what energy and power is, in simple words. We will talk about this a lot throughout the course. That's why I'm just talking about this briefly, really briefly. So this is basically it for an introduction. So follow me to the next lesson, and don't forget to subscribe. That is really important to me. So have a lovely rest of the day.